Okay, having a look at congruence and quadrilaterals. So the thing we need to remember is our F, U, and Z rule when we're doing this, and mostly our Z rule. So our Z rule in parallel lines means that we can say that B and F are equal because of the Z rule, so we call them the alternate angles. We can also say that the corresponding ones are equal, where we've got our E and G type ones. And we can also say that our co-interior angles, so the angles inside the U, they have to add to 180. All of those ones can be useful. A lot of the ones we'll use are the Z rule. So having a look at this example down here where we have a quadrilateral, so in this case we've got a parallelogram, we're trying to prove that the diagonals bisect. So that means we need to find, and I should have had an E here, these lengths here so that this one is equal to that and this one is equal to that. Now we could go about it a few different ways. I'm going to concentrate on these two triangles here and try and, if I can prove that they are congruent, then that means that this one would be equal to that and this side will be equal to that one. So I've got to work my way through that and try and prove that they're equal. So for starters, I know that the length AB must be equal to the length CD because I've got that little notation on there. So I already know that. Now I want to think about what angles I can prove using the Z rule in that triangle. So if I use the Z rule this way, I can say that these two angles would have to be equal. So I can say that angle B must be equal to angle D. And then I can use the Z rule the other way to prove the other two angles. So then I can say that angle A must be equal to angle C. I also know that angle E is common to both of them. And the reason that those two angles are equal there, so if we're looking at that particular part, they are opposite angles. So I also have that as well. So I actually have the three angles in there, but I needed that one side to prove it because that had to be between the two angles, and it's between these two outside ones rather than this one here. So I didn't really need that piece of information, but I do have it anyway. So because I've got that, I can say I can say that angle side is my reason, but that then implies that triangle BEA is congruent to triangle CED, which would then mean that these sides are also equal. So then that would prove that that diagonal bisects each other. So you're going through that process of finding what you can find out for each triangle and match up those things that you know on both triangles and as many angles as you can, and just go through all of that. So looking at your angles, looking at your sides, getting those three pieces of information that you need to prove that they are congruent. And then once you've done that, then that should be able to help you to prove whatever it is the question is asking in terms of those quadrilaterals.